We've been talking about the Bohr model for the hydrogen atom, and we know the hydrogen atom has one positive charge in the nucleus. So here's our positively charged nucleus of the hydrogen atom and a negatively charged electron. And if you're going by the Bohr model, the negatively charged electron is orbiting the nucleus at a certain distance. And so here I put the negatively charged electron a distance of r1. And so this electron is in the lowest energy level, the ground state. So this is the first energy level, E1. We saw in the previous video that if you apply the right amount of energy, you can promote that electron. The electron can jump up to a higher energy level. And so if we add the right amount of energy, this electron can jump up to a higher energy level. And so now this electron is a distance of r3. So we're talking about the third energy level here. And this is the process of absorption. The electron absorbs energy and jumps up to a higher energy level. This is only temporary though. The electron's not going to stay there forever. It's eventually going to fall back down to the ground state. And so let's go ahead and put that on the diagram on the right. And so here's our electron, right? It's at the third energy level. It's eventually going to fall back down to the ground state, the first energy level. So here's the electron going back to the first energy level here. And when it does that, it's going to emit a photon, right? So it's going to emit light. So when the electron drops from a higher energy level to a lower energy level, it emits light. This is the process of emission. And I could represent that photon here. This is how you usually see it in textbooks. So we emit a photon, which is going to have a certain wavelength, right? Lambda is the symbol for wavelength. And we need to figure out how to relate lambda to those different energy levels. Right? So the energy of the photon is the energy of the emitted photon is equal to the difference in energy between those two energy levels. So we have energy with the third energy level and the first energy level. Right? So the difference between those, so the energy of the third energy level minus the energy of the first energy level, that's equal to the energy of the photon. This is equal to the energy of that